Hello, in this video we're going to be doing checkpoint 5.2. A couple of problems here. First, they want us to use the properties of the double integral in Fubini's theorem to evaluate this double integral. This is the integral of 3 minus x plus 4y dy, y going from -1 to 3, and then x going from 0 to 1. After this, they want us to show that this double integral from over the region R of sine pi x times cosine pi y dA is going to be between 0 and 1 over 32, where your R rectangular region is going to be 0 1/4 and 1/4 1/2. All right, let's attack this one first. Fubini's theorem tells us that when we see a double integral like this, we're going to treat it like an iterated integral and work from the inside out. Now this inside integral will eventually become like an area function, area with respect to x, and then we'll integrate that with respect to x going from 0 to 1 after we figure it out. So first we need to figure out what a of x is equal to, and we will integrate this with respect to y. And when we integrate with respect to y and plug in the values for y, all the y variables should disappear and it'll just be a function of x. And then we can imagine each of these slices for different x values would give us a function of x, and then we're going to integrate that like an area function, like the volumes by slicing kind of deal. Okay. With respect to y, this is going to be 3y. X is a constant, so this would be minus xy, and then that third one is 4y squared over 2, which is going to be 2y squared. We're going to evaluate this when y goes from -1 to 3. And just some comment on this. You don't have to put y equals. You can just put -1 to 3, but it's just good practice that we're going to saying that we're going to evaluate these for the y, not for the x, since there's two variables there. It could get confusing. First, we put the 3 in there. We're going to get 3 times 3 is 9. This is going to be 3x, and 3 squared is 9, times 2 is 18. And we're going to subtract when we put -1 in there. That's going to be a -3. Running out of room. So let's do it on the next line. It's going to be minus -3. -1 times negative x is positive x. And -1 squared is 1, times 2 is positive 2. So we'll add this, and we will get 9. Well, let's start with this one. -3, -2 is -1. Make that a positive 1 with the negative sign, and then that's going to be 10 plus 28. 10 plus 18 is 28. So we have a 28, and -3 minus x is -4x. So that's your area function, and after we find our area function with respect to x, we're going to evaluate that with respect to, or after we find an area function of x, we're going to integrate that a of x from 0 to 1. And when we integrate this is simply 28x minus 4x squared over 2, so that's 2x squared. And this one, your x values are going to go from 0 to 1. So this is just 28 minus 2, and then put zeros, and you're going to get just 0. So 28 minus 2 is 26. And that should be your double integral, and treat it as if it was an iterated integral. All right. That's our first part. Part 2, they want us to show that this double integral is between a couple of values. And so you have to remember the formula, I think, that they put. And if m is between some function, if some function f of x, y is between little m and big M, then the integral little m times the area times the area of the region is going to be bounding that integral over the region. So this is our goal, or this is the formula, the property that we're going to use. And so we just have to look at this function and see if we can find a boundary for it, a bound for it. Okay, so for that we will consider, since this looks like it's a product of two things, we can consider each of them separately and just do some sort of multiplication. Like, for example, the sine pi x, oops, that's pi times x, not pi over x, sine pi x. The sine function generally goes between -1 and 1. That's for all real numbers. But here we're just going to go from 0 to pi. So let's imagine the sine function here on the side. Sine function starts from 0 and it goes up, and it goes up to reach its 1 at pi over 2. But we're not going all the way to pi over 2. We're stopping here at pi over 4. And I say pi over 4 because your x value goes to 1/4. And so pi times 1/4 is just pi over 4. And so your small value here is 0. That's what happens when x is equal to 0. And when x is equal to when x is equal to 1/4, we have sine pi over 4, which is √2/2. So we can say that our sine function is bounded between 0 and √2/2. Now let's look at the cosine of y, or cosine of pi times y. And let's see if we can find a boundary for that. And let's draw a graph. Cosine function from 0 to pi over 2 looks like that. This is 1, this is pi over 2. But we're going to go from 1/4, which is cosine pi over 4, and that's going to give us, again, √2/2 value, and then it drops all the way down to 0. So this one looks like it has a minimum of 0 and a maximum of √2/2 again. So a minimum of 0, a maximum of √2/2. And so that is going to be the boundary for each of those individual functions. So if we put these functions together, we can just multiply them all out. So 0 less than or equal to, now the combination or the product of these two functions, sine pi x times cosine pi y, is going to be between the product of these two, √2/2 times √2/2. What is this? 2/4, that's 1/2. So 0 less than or equal to sine. Actually, instead of rewriting that, let's just say that this is 1/2. Okay. All right. So that is the boundary for our function itself. And now if we're going to look at this over a rectangular region, we need to find the area of the region. Well, what is your region? Your region looks like R is from 0 to 1/4 and from 1/4 to 1/2. So from 0 to 1/4, 1/4 to 1/2. Okay, that's just a square. Each square has side length 1/4. And so the area of the region looks like it's going to be 1/4 times 1/4, and that's 1/16. Okay, so that is our area, and now we multiply each of these, by the area according to the property. So 0 times 1/16 is 1/16, and 1/2 times 1/16 is 1/32. So that is our exactly what we want to get at. So the double integral over the region that we're looking for, and the sine pi x cosine pi y dA, and that's going to equal to, oops, not equal, but it'll be less than or equal to, and then here is where we multiply 2 or 1/2 times 1/16, so that's 1/32. Okay. All right, so that's the bounding properties or the limit properties for the double integral, and that is it. I hope that helps.